plants use a lot of water. That's pumping their hives, using boilers, a lot of water on the plant. Gains a lot of pressure, gains a lot of solvents, it gets something to right? This pond holds all the water, all the solvents, and the ponds are open in there, ideally designed to evaporate as much water as they can to. Now, unfortunately, sometimes spec doesn't go. We are now a whole year-round power plant that will vent out throughout the world. So, as a result, now once that water gets to a certain level, we're going to have to shut down the plant. Water pumping water out of the plant, using water. Current solutions out there doing this, and one of the best solutions right now is to spray the water into the air. Sorry, these pictures might be a little big or small. You see right here, they're spraying water into the air, including all the particulates and everything along with that. Now, this is the best way to evaporate the water is. The issue is the counties, as well as the EPA, is regulating more on this because it's destroying the environment around it. And Clark County is even more strict than the EPA. So Clark County does not allow for spraying. So any power plant that's within the Las Vegas, Clark County area does not allow to spray water into the air to evaporate. Now there's other solutions as well. You can truck the water out, which is really just shifting the problem over from one side to the next. Eventually, I mean, here right now, NV Energy owns pretty much all own power plants, so they're going to have to take that water out again. Or you can filter the water, which is very expensive. What we wanted to do is we wanted to create a solution that would be environmentally friendly, not destroy the water, or not just destroy the environment around it, be feasible, as well as fitting to the power plant that we designed it. So because evaporation is a surface phenomenon, we thought, hey, what if we were able to spread the area, increase the area that we're working in, aerate the water a little bit by having the surface turn down, and add some heat to the water, attracting the sun as it's moving.
Fifth scale of what you would expect, and kind of the design criteria that we've fulfilled that in line to fifth scale that we implemented. This surface here is going to be a wear surface, so you're going to get grooves in it, and then it's not going to work as a monolayer. So we want to be able to take out this sort of piece of unused sheet metal. We want to be able to remove that and then replace it. So we're going to use a solid piece of sheet metal so that it's easier to replace. We unscrew it, we just repiece it on with the coating on it, black body coating, and a sheet. It's about $150 to do that maintenance, and we assume it's going to be approximately a year or annually. And as far as maintenance, that's what we anticipate being. As far as there's some flaws here, we have our fasteners here. Obviously, you can see they're rusty. We did some rusting on top of the roof, like PVC. So you see some rusting, so we should fix those fasteners. But as far as the end design, we should just be able to take that surface off and replace it. This one here, when it's full scale, we're estimating it's going to cost about $1,800. You're going to need more than one. We're creating it so it's modular, so different size plants. You can have a 1 acre power plant, in our case, we're working on a 7 acre plant. Roughly about 28 units, so $1,800, 20 units. If you look over here,
the water from that 7 acre pond, and then it will go on this.
correct.
And then how much of this evaporate? Like,
How much of this will evaporate? In our test results, in a small scale as this, we received just over 2 times increment. Or
Natural evaporation.
Yes. So we erased natural evaporation. We had 2 times more of natural evaporation is what we see.
so you keep running this until everything.
Right now it's so we don't expect this to completely evaporate the whole pond. Our scope is to try to keep up as best as we can with the input that's coming in. Not try to exceed that a little bit more. in terms of cost, we ran checked some of the other solutions that they have, whether it's cleaning water, other aerators, and based on some of the units closer to $25,000, $50,000, $75,000 a piece, you need multiple units per acre, depending on the acre size. You're looking at quite a reduction in cost.
On top of that, you would assume that the main way that they used to evaporate is to spray it in there like this very successful method. It's getting shut down. You can't do that anymore. So you're starting to see the pond level drop. If that pond level fills up beyond government regulations, they're going to have to shut down the power plant. And
Even in Las Vegas, where we have plenty of sun here.
Right.
This thing doubles the evaporation.
Yes, sir. Yes, sir. I think we're actually testing in ideal conditions. So some other tests that we would like to run is trying to see how this would work in possibly more humid climates or...
Oh, go ahead, Hunter.
No.
Oh, yeah, well, to clarify, 2 times the natural evaporation rate of a pond is just sitting there.
correct, the small pond.
Okay.
So you're not the 7 acres, not 2 times.
How does it compare to spraying in the air?
Spraying in, we won't have as good of evaporation as spraying in the air that
You have some. I mean, they're expensive.
Yeah.
They cost more,
Yeah.
but are they more effective on a per dollar basis? I mean,
Yes.
how is that?
They're definitely more effective by a per dollar basis, but they're illegal to use.
Yeah, they're not.
No, I get, the aeration system, I mean, the one where you filter it, that's not illegal, right?
Right.
But just, maybe that's more expensive. Per unit of volume that you're processing,
Yeah.
do they compare? How much does it cost for a gallon to aerate? You follow me? That kind of thing. Is it the same? Is it more? Is it less? How do you look?
Yeah, we have looked into, you're talking about filtration of the brine, right?
Well, or whatever other method. Yeah, I mean, you got 2 or 3 methods you suggested a couple competition, right?
Yep.
Aeration, which is illegal, maybe something like that. Filtering.
The brine filtration itself has its advantages. It definitely does, but one of those systems to buy and bring onto your site, you're looking at millions of dollars. This is a cheap alternative that you can implement. Modular, we made them modular so that you can build several units to help evaporation, and if you need more, you can expand on those modular units that way. As far as you have a low buy-in cost, that's kind of where you get there.
You said you applied heat.
On here, we're not applying heat, we're using solar. So it's a black bar, and that's where the solar traffic is. So we're using velocity of this. We're using aeration from it dumping in here, and we're also trying to thin this layer out as much as possible. And that's kind of where we got the idea to improve. We wanted to implement on the second phase, if we keep expanding on this, we would like to change the flow of this based on the heat flow.
We did the calculations, they're not coming to mind right now, but on a thinner film of water. But that's an improvement that we want to make in the future, is to be able to control that flow of water based on the solar flux that we're getting into the surface, which will allow us to evaporate more water. Unfortunately, we weren't able to do that this time, but we had this one flow that we can dampen a little with, we have some rocks in there to try to dampen that flow.
Agile engineering.
Yes, that's another implementation.
Sorry.
We want to try different methods. We're looking at different surface treatments, possibly even what is going to
There's a couple different panels that we want to check together in phase 2 that we want to do on this. One of them would be using baffles. That way you would increase surface area, so we think that would be great as far as that. We were concerned when we did this in initial testing of the expansion of it would buckle it as it sticks. When we put it on the roof, we haven't had any kind of buckle. We've been to maintain this surface. So we're going to go to the baffles so it will expand in the joints with that. One of the other systems that we were looking into and possibly doing in phase 2 is there's a mesh that's very tightly knit that would be able to flow through, but you'd also be able to use the airway to act kind of like a swamp cooler. And we think that's a very viable.
So we know cooling towers evaporate a ton of water, so we wanted to try to mimic that.
There's very heavy salts, and so currently in the natural evaporation that they're using, even if they spray it up, those salts come back down, right? And they're filling the pond, so after a certain amount of time, depending on the regulation,
You get a thick sludge at the bottom. You get a thick sludge, and then you gather and take it, scoop it out and dump. And it's much easier to handle into, I guess, like local dumps. It has to be taken actually by almost like a hazmat team. So you can't just have somebody that's working at the pond come and scoop it up and take it away.
You said you were working with
We kind of discussed it with them. We're not directly relating to them. We've got a couple of meetings. We were able to get water from them. This isn't actual test water because that water stinks. We were using actual water. reduction. So we had live data where potentiometers were close, so we can take the voltage and then convert the length of it. So we had volume change. We were able to get that. We also had relative humidity. We tracked all in one sensor type. So
we using the data logger to track it along with the relative humidity.
Honestly, about it, and they said obviously they have enough energy. That's not one of the constraints. You know, if they have the hookup for it, they're not worried about it. It's not.
He said when we talked to him, he said, "Dude, we're a power plant." Like that's not the issue. We need you to get rid of this water.